All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up number 62 is on the screen. Now, we've been going at this warm-up for about 2.5 weeks or so, I want to say, because we're coming up with these lessons that require all these skills. They're coming up, and like I mentioned before when we started the semester, it's going to starting to come a little bit faster. You're going to notice that today we're going to add one more parameter. So make sure you stay on task. No electronic devices today, so put them away, please. Today we're going to old school, so pencil and paper, okay, just to save time and move us along. So warm-up 62 is on the screen. Let's get cracking. Oh, and congratulations to sports people and extracurricular stuff. I heard you guys are doing really great. And earlier I was reminded when I wrestled, and I'm going to show you a picture and see if I can find it. I wrestled Miss X. Very good. -8 plus 3. Man, very detailed. Hands, if you got that. That is correct. And once again, the last one, number 4. Share with me what you got for number 4 before we call someone. I want the inverse. The inverse. Inverse. All right, let's see. How about Briseida? Hands, if you got that. That is correct. Let's go. So once again, warm up. Like I said, we're about to get into inverses. We're about to get in quadratics, more deep into quadratics. We are about to get into imaginary and complex stuff, and we're going to apply it now to other things, such as real world stuff. And just giving you a heads up. Before coming to education, I used to be an electronics specialist, so I know how these numbers work in electronics. So we're gonna do some stuff with that, so you guys can see some of the components of electronics and how that works. All right, copy the agenda for today. Agenda warm-up number 62, transformation of functions. Your home plate for tonight, transformations on 5 only. Last night's home play that you did over the weekend, that's a gift from me to you. That was just extra practice. However, the home play, you do need to take a picture, get your phones ready. All right, there it is. And if you notice, it's got a lot more stuff, so make sure, just for the sake of today, even though it's Monday, today I am staying for tutoring, just to answer questions and make sure we finish the home plate here on campus before you leave. So after school, be there or be elsewhere. Yeah, there you go. All right. So with that said, let's get a Cornell note ready, please. And also, you do need a Ferri model. And underneath the Ferri model, can you get a coordinate plane ready that's from -10 to 10? On the Y and -5 to 5 on the X axis. I'll give you some time for that. Go. All right, here we go. I can transform a function using different parameters. So, we're still in the concept of what? Functions, yes? So, in your Ferri model, make sure you write function. And by now, without any notes, tell your neighbor the definition of a function so they can write it in there. Since we are experts at it, we've been going over the definition almost every day. All right. Definition. Bless you. Who went last? Oh, Briseida, pass them on. Lorena, definition. So one input with one exact output. So far so good, but it starts with two words. A relation, yes, a relation. Now, just to recap, what is a relation? Let's see. It's a set of points, negative 1, 1, 2, 3, 5, 8. That's what a relation is, yes? However, what makes it a function? Here it goes, for those of you that forgot. That whenever one of these repeats, it has to have the exact same output. So I'm going to repeat the number 2. What should be the output? 3. That is correct. It has to have the exact same output. So with that same idea, right over here, negative 1, 1, 2, 3, 5, 8, and add one more for it to be not a function, not a function. All right, share with your neighbor before I call in Jaden. All right, Jaden, go. Which one do you want to repeat? Negative 1, 2, or 5? 5, and then 3. Yes, this is not a function because it should have had a what here? It should have been a what? 8. That is correct. The other thing that you should have written for an example would be an example of what it looks like. F of x equals what? X squared. Yes, that's a function. What doesn't it look like? X squared. What's the difference from one to the other? That one of them has a what? F of x equals, and the other one without an equal. So it has to be an equation. So, hashtag what? Equal, yeah? Equal sign. And hashtag, what made it a function over here? That it was what? That it was what? Exact one output. Yes. All right. So, we got that. We went to these transformations, and we ended with some of these and such. So, here it goes, and I'm going to go over this before I get into the new part, because today we're adding more to it. Before I move on, I'm going to do a quick review of everything we've seen for the past 2-3 months in transformations. So, writing utensils down, everybody's focused up here. So if you're one of those that are behind with your transformations, stay focused, because here it goes. I'm going to give you everything from the beginning. So don't copy this, just pay attention. In transformations, we said we were going to start writing two variable equations in function notation. So we started with f of x equals x. From there we graphed that. And we said use the domain from -2 of x, -1, 0, 1, and 2. Only those. So if I substitute -2 here, I get -2 here because it's the same x. That's why I go -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And what do we notice? That it's a straight line. This is a linear function. From there, we went to f of x equals x squared. And again, if we use from -2 to 4, but we square it now, what is -2 squared? Positive 4. -1 squared, 1, 0, 0, 1, 1, 2, 4. From there, we went to f of x equals x cubed. This is a linear, this is a quadratic, and the graph for this one is a combination of these two. It looks like a line, but it's got a curve to it. That's why this is a cubic. So if I start with -2, -2 cubed is -8. Negative 1 equals to negative 1, 0, 0, 1, 1, 2, 8. And it looks like that. So, another thing that I brought up during all these times that we've been transforming functions is that the 2 points that all parent functions, these are parent functions, the points that all parent functions must go through is 0, 0, and 1, 1. So that means that if I introduce a new function, what 2 points is it going to go through? 0, 0, and 1, 1. If I introduce another one, 0, 0, 1. We still have plenty of more that I'm going to bring in here, 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 and they're going to keep growing. Like I said, this second semester is going to be packed, okay? But I'm just going over this to make sure we're on the same ball. So far so good, yes? All right. From there, we started with transformations. So we did this. F of x equals x squared, and I said graph that without a table. So you start at negative 2 squared is 4, negative 1 squared is 1, 0, 0, 1, 1, 2, 4. And I said label that f of x. From there, we introduced 2 parameters. I introduced first the first one, and then the second one. I'm going to combine both. And if I wanted for you to graph the next portion, it would be like this. Bless you. X minus 5 plus, give me a number? 7. So check this out. Oh, and since it's a square, I need to put a little square there. Now we have 2 parameters in there, k and h. K, this positive 7, takes the whole function in which direction? Up. And the positive 5 takes it into the right. That means I move all of these points, 5 to the right, 7 up. So I'm going to start with this one. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And then this one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And we label that what? G of x. Next, what if I didn't want to go that direction and I gave you this one? So any ever which direction we're going to move the original one to? Where is that going to move to? It's a bell. To the left and then down. That is correct. 8 to the left and 3 down. So that means I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. And that's my new g of x. So far so good, yes? All right. Next, what if I wanted to do this? First, where am I going to move the whole thing to? Tell your neighbor, please. Where is it going to move to? Yeah, 3 to the right and 4 down. However, before I move it, I need to do this, which is A. If it's a whole number, it's going to stretch vertically. How do we know that, Mr. Q? Because I look at these 2 points, I need to stretch these 2 points. What is the y value? The y value is 4, but I multiply it times 2, so that gives me 8. That means these 2 points, I move them up here and here. Next, look at these 2 points. What is the y value? The y value is 1, but if I multiply that times 2, my new value is 2. So that means I'm going to go here and here. Now I have a stretched parabola. But am I done? No. 3 to the right and 4 down. So I'm going to take this one. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Yes? One. What's that? This one? Yeah, I did that to see if you were paying attention. There you go. Now this is GLX. Okay. So far so good, yes? That pretty much encompassed everything that we talked. Oh, I'm missing one thing. Look up. What if I said for this one I want it to be with a negative in front of the x squared? Tell your neighbor what it does to the original according to that negative. Everyone, it flips it, yes? So instead of having here, I just bring it over here. Okay. So far so good. Before I move on, one last thing. Some of you saw it, some of you didn't because you were busy with all the transformations, but let me show you something. Check this out. Look at the blue one. What is the value of H on the blue one? 5. What is the value of K? 7. So 5, 7. This is H. This is K. Okay. Look at the red one. What is the value of H? -8. What is the value of K? -3. Look at the green one. What is the value of H? +3. How about K? -4. Well, guess what? Check this out. The original does not have H and K, is that correct? No H, no K. So what is 0, 0? This is known as the vertex, 0, 0. But look now with the transformation here in blue. What would be my new vertex? 5, 7. Let's see the blue one. Is this one in 5, 7? 5, 7. Yes. Look at the green one. 3, -4. 3, -4. Let's go. Let's go. Get that out of here. And the last one, -8, -3. -8, -3. There it is. We good? Or like I used to say on the court, get that out of here, little boy. Oh, no. All right. So from 1 to 5, how comfortable are you with all the transformations up to right there? Okay, 5, 4, 5, 4. We got it, right? All right. Copy this next one on the coordinate plane that I asked you to write on the side or underneath the Frere. Copy this one. It says, example Michael Jordan cube, and it says the graph f of x equals x cubed is shown. So here's the graph. Copy that. And then we're going to graph this piece. So copy that, and then I'll come right after so we can do the work together. All right. So here we have a qubit function. Yes? So far so good. All right. So you can see the table for that one. Let's make a table for these points over here on the side. X, f of x. And the first point, this one down here, is -2, -8. Right? -2, -8. Next point right here is -1, -1. Next one is 0, 0. Next one is 1, 1. And last one, 2, 8. 2, 8. Okay. Now, if you notice this is a little bit different from what we did with A. A, we wrote whatever number multiplying f of x, but this one now has a number inside multiplying x, which means we're not going to use the original function, the table, we're just going to use the values of x. So to do that, I'm going to switch to blue. I want you to write x, elongate the table because we're going to do a lot of work over here on this side, and I'm going to write f of 1/2 x, or 1/2 times x cubed. All right, I'm going to zoom in. So my first x value is -2. So I'm going to write f of 1/2 times, what is x now? X is -2. Close parentheses to the third power. On the next step, I'm not going to write the f just for the sake of space, to save space, but I'm going to do the work inside. So what is 1/2 times -2? -1, yes. Put that in parentheses, and we're going to cube it. And at the end, -1 times -1 times -1 is -1. Do the next one. Next value is -1. F of 1/2 times -1, cube it. Once again, on the next step, I don't use the f, so this is 1/2 times a -1 is -1/2. We're going to cube it. Start with the symbol. Negative times a negative times a negative, negative. Start with the numerator. What is 1 times 1 times 1? 1. Denominator. What is 2 times 2 times 2? 8. That is correct. All right, now that I showed you the work, I want you to do the last three of them together by yourself. 0, 1, and 2. Fill in the work, please. All right, answers on the screen. Let's see if you got something like this. Hands, if you got that? Yeah, we got the work, right? All right. So for tonight's home play, remember, make a table for the 1/2, 1/4, or 2x, or whatever they're going to give you for the multiplier of x. But for h and k, you don't need to make any tables. Just at the end, move the entire function according to h and k. We already know how to do that. So let's plot this to see what happens. Here we go. -2, -1. -2, -1 is right there. Next value, -1 and -1/8. -1, -1/8 is very close to the x-axis. 0, 0, 0, 0. 1, 1/8. 1, 1/8, very close to the x-axis. And the last one, 2, 1, 2, 1. Let me zoom out. All right. Talk to your neighbor, let them know one word that you would describe what happened to the original to get that. What happened to the original to get that? One word. Then we'll call on Valente. What's that? Yeah. All right. Yeah, let's go with Fabian. Fabian, let's see. What is it? One word that you would describe happens to this to get that. It shrunk, not really. JP. Vertically squash, horizontally stretch. So the key word here is stretch. That is correct. Write that down, please. And yes, notice that it stretched in side directions and horizontally. Okay? So today we're introducing a new parameter that's going to be horizontal, either stretch or compress. So notice here, look up please. Notice here, even though we have a 1/2 in our general rule, the only thing we're going to be looking at is the denominator. The 1 will always be right there. But today we're introducing the denominator, which makes it into a fraction. So write this rule down, please. Here we go. G of x equals a times f of 1 over bx minus h, close parentheses, plus k. You're like, oh, snap, it keeps getting, yes. We're going to talk about that right now, yeah. All right, check this out. Start with the first parameter that we introduced when we first started this whole idea of transformations, which was what? Which one? K, all right, well, circle K. See what it did there? Never mind. If we substitute a positive value, it goes what? Up. If we substitute a negative value, it goes down. That is correct. Next, box H by itself. If we substitute a positive value, it goes to the right. If we substitute a negative value, it goes to the left. And this is something that some of you are still struggling with. Listen to the word, substitute. If I substitute a -5 in here for h, what is -5 times negative? It becomes a x plus 5. So be careful with that. Next, the next parameter that we introduced was a. So what did a do? A stretched, stretch or compress. Stretch if it was a whole number, or compress if it was a fraction or decimal. However, in which direction did it stretch or compress? It did it vertically. Vertical, stretch or compress like this. Okay. Today, we introduced a new parameter, which is the letter b. Not the fraction b, because if you notice, look up, the 1 is always there in our general rule. Think about it. What's the invisible number here in front of x? A 1. So what's the only thing we introduce? The denominator of b. That is correct. So, if we substitute in there a whole number, everyone, what does it do? It did stretch. Let's see. What number is substituted in here on the denominator? The number 2, right? So it's stretched. Yeah. So be careful, yeah. Our noodle's like, wait a minute, it's a fraction. So, yeah, whole number, stretch. So, what do we need in there, here in the denominator, in order to compress? Tell your neighbor, please. What do we need in the denominator to compress horizontally? Valente. So if it's a whole number to stretch, what do we need to compress? What kind of number? Lucia, help him out. Fraction or decimal. That is correct. And this stretch and compress is like this. Horizontal. Horizontal. Now let me clarify, some of you that are going to be having some doubts when we do the transformations for home plate. Look up. I'm going to write this portion. This portion right here. Right here. Okay? I'm going to substitute a fraction. Here it goes. Instead of b, I'm going to substitute a fraction. Let's say 1/2. Doesn't that look funky? Yes, we can't have fractions under fractions. And I covered this when we introduced rationals. How can I get rid of that fraction? By writing the reciprocal of the fraction that I substituted. So what is the reciprocal of 1/2? 2. So this becomes, check this out, f parentheses 2x. Copy that, please. Yeah, you're like, what? What? On the side, I want you to make one more for yourself. F of 1 over bx. F of 1. All right. Give me a fraction, Ivan. What is it? 1/10. Okay, 1/10. All right. So tell your neighbor what this f of 1 over 1/10 x becomes, please. Close, yeah. 10x, that is correct. Hands, have you got that? Yes, and so on and so forth. So when is it that the only time that we're going to have a fraction multiplying x? Whenever the number is a whole number. Because if I substitute here 3, then I end up with 1/3 x. Okay. We got it? Yes? All right. So now we have 4 parameters, guys, like I said, and I promise this second semester it's going to start building up pretty quick. So stay with me, okay? So for the sake of having some, let's do some noodle work, yes? Write your utensils down. I'm going to give you a function. Don't write it down. I'm going to give you a parameter to substitute, and you should know what it does to the original. Here it goes. Original. What does it do according to that? Alessandra. Stay focused. All right. JP, what does that do to it? Flips it. Why? Because the A right here is a what? Negative. It's going to flip it upside down. So far so good? Here goes another one. Pay attention. Tell your neighbor what that does to the entire function. Noel. It's going to stretch vertically. Yes, it's going to be right about here. Yes? Look at this one. Tell your neighbor what that does to the entire function. Jose. Compress it vertically. Yes, that is correct. So we end up with that one right here. All right? That one. If I substitute the 2 there, tell your neighbor what it does to the entire function. Frida. Stretches in which direction? Horizontally. That is correct, because we end up with what? 1/2 x, so it's going to be over here like this. H is a positive 5. Tell your neighbor, please. All right. Christina. This is an H. Fredo. close. This is a positive 5. It goes to the right. It's a positive 5 that we're substituting for x. Is that correct? Positive number, go to the right. Okay. Here it goes again. Look up. If I substitute this in here, it's still a positive. And I end up with x minus 5. It's still a positive 5. It's going to the right. No. Remember the last two steps we only do for where it's moving. We only do the multiplication for what? For this or that. All right, next one. Where is that one going? Jaden. To the left, yes. If I substitute a negative for h, it goes to the left. Everyone. K is a positive 3, it goes up. A is 1/4. Compresses vertically. H is a positive 8, it goes to the right. Yes. No. Guys, the general rule, it doesn't matter if it's square, cubic, quartic, quintic, whatever. This continues to remain a positive number that's going to move it to the right. Here goes another one. Everyone. Down. All right? Here goes a challenge one, and I'm going to call on one of you. Here it goes. On one of you. Tell your neighbor one piece by piece what's going to happen to the entire function. Talk it over to your neighbor, and I'll call on someone. All right, let's get started. Get us started with the first part. Julian, what does a negative 1 do to the entire function? Flip it. Yes, that is correct. So far, so good. Hands if you got that. All right. B equals 6. Anaya. Stretch. In which direction? Yes, horizontally. Hands if you got that. Yeah, because if we substitute that in here, it's still a whole number being substituted into B. Okay? Next, pass someone. Jessica? Left. That is correct. And last but not least, pass someone. Who? Fredo. Up. That is correct. Those are all the transformations that are going to happen to this. So if we flip it, check this out, upside down, stretch it horizontally, move it to the left and up, that means it's going to end up somewhere over here. Okay? All right. Last but not least, copy this one, please. I'm going to get you at least started. G of x equals negative f, parentheses, 1/2 x plus 6, close parentheses, minus 4. And since they give us the parent function of squared, put the square right there. All right? So, to get us started, what does the 6, or this number in here, and the negative 4 do to the entire function? Go. Tell your neighbor. Huh? This one and this one. Alyssa, go. It goes down, that is correct. And left, that is correct, because what we substituted in there was a what? a negative 6. All right, so what is the only thing we need to worry about for right now? That one. That means for your table, in your home plate, you write f 1/2 x, and now it's a what? Quadratic. So my first value is negative 2, so I do f 1/2 times negative 2 squared. So what is negative 2 times 1/2? Negative 1. What is negative 1 squared? 1. Next, negative 1. F of 1/2 times negative 1 squared is negative 1/2 squared. So what is negative 1/2 times negative 1/2? That's 1/4, positive. 0. F of 1/2 times 0 squared is still 0. 1. F of 1/2 times 1 squared is 1/2 squared, which is 1/4. And 2. F of 1/2 times 2 squared is 1 squared, which is 1. So that means, what did this do? Let's see. Negative 2, 1, negative 2, 1, negative 1, 1/4, 0, 0, 1, 1/4, 1. Stretches a bit horizontally. However, what are my last two steps? 6 to the left and 4 down. That's going to be your home plate, by the way. Okay? Tutoring after school, be there or be elsewhere. Have a good one. See you guys tomorrow. Bye.